Okay, so today we are going to um, use or learn some of our rules of exponents. Specifically, we're going to talk about zero and as an exponent and what happens when we have negative exponents as well. Okay, so we're going to actually start by going back and reviewing for a quick minute some of the rules that hopefully you already know, specifically the multiplication rule and the power to power rule. So multiplication rule, a to the third times a to the fourth. If I were to really expand this out, a to the third means like a times a times a. And then I'm multiplying that by a to the fourth, which would be like a times a times a times a. So if I think about how many a's am I actually multiplying together, that's 7 total a's, right? Or in other words, a to the 7th. And that's where we get our multiplication rule. Our multiplication rule is that we should add the exponents of like bases. So number 2, I also have this coefficient, so I'm also going to multiply the coefficients. There's an invisible 1 here. So I'm multiplying 1 times 7, which is 7. And then if I multiply a squared times a to the 8th, I have 10 total a's, because 2 plus 8 is 10. And then b's, I have 3 b's here, but then I also have 1 b here. So remember, just because there's not an exponent, there's an invisible 1 there, right? So I have 4 total b's, or in other words, b to the 4th. Number 3, I'm going to multiply the coefficients. Again, my coefficients are 6 and 3, so 6 times 3 is 18. And then I'm going to look, how many x's do I have? I have 3 plus another 2, so x to the 5th. I have some y's. I have 2 total y's, right? Here's 1 y and here's 1 y. And then I have z to the 5th. Okay, power to power rule is really the multiplication rule as well, because this means c to the 5th to the 3rd power. So it means like c to the 5th times c to the 5th times c to the 5th, right? And we know that c to the 5th is really like 5 c's. So if I think I have like 5 c's and another 5 and another 5, that's 15 total c's. So my power to power rule is that I can multiply the exponents because I really have like 3 groups of 5 c's, or in other words, 15 total c's. Now the coefficients, this 6 here, I'm going to raise everything to the 2nd power. So 6 is not an exponent. The 6 is a 6. So 2 to the 6th power, I'm sorry, I said that backwards. 6 to the 2nd power, 6 to the 2nd power is 6 times 6, or in other words, 36. And then here's an exponent. That 7's an exponent. So think about it. I have like 2 groups of 7 x's. So if I have 2 groups of 7, I have 14. I have 14 x's. So 6 squared is 36, and then I multiply the 7 and the 2. Very similarly, number 3, I have negative 4 to the 3rd power. Well, that means negative 4 times negative 4 times negative 4. So first of all, negative 4 times negative 4 is going to be a positive 16. But then when I multiply a positive times a negative, I'm actually going to get a negative. So my answer here is going to be negative. And 16 times negative 4 is negative 64. And you can use your calculator for this. But so I'm going to get negative 64. This is a to the 1st. And again, I have like 3 groups of 1a, or in other words, 1 times 3. So a to the 3rd. I have 3 groups of 3 b's. So 3 times 3 is b to the 9th. Final answer. Okay. All right, so let's talk about these 2 new rules. What happens when I have 0 as an exponent, and what happens when I have negative exponents? These are going to look really tricky at first. It's going to look like, oh my gosh, what am I doing here? But it's actually pretty simple. So let's start here. Math is all about patterns. So we're going to think of this, our exponents, as a set of patterns. 2 to the 5th really means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, right? And that's 32. 2 to the 4th is 2 times 2 times 2 times 2, 16. 2 to the 3rd, we can think of as 2 times 2 times 2, right? We know that's 8. Now listen, another pattern I want you to notice is that if I go from 2 to the 5th to 2 to the 4th, I can really think of this as like dividing by 2. 32 divided by 2 is 16, right? 16 divided by 2 is 8. And really going backwards, or going like up, 8 times 2 is 16. 16 times 2 is 32, right? So think about the pattern being division, though, okay? So 8 divided by 2 is 4. Well, I know 2 squared is 2 times 2, which is 4, right? Divide by 2 again, 4 divided by 2 is 2. 2 to the 1st is 2. That makes sense. I know these things. But what's 2 to the 0? My students are always like, oh, it's 0. But with that, follow the pattern. If I divide 2 divided by 2, what do I get? I don't get 0, I get 1. And further, 2 to the 0 definitely can't be 0, because if the pattern going up here is that I'm always going to multiply by 2, right? Always multiply by 2. If 2 to the 0, if 2 to the 0 were 0, if I multiplied by 2, what's 0 times 2? It's 0. So that couldn't work, right? All right, so 2 to the 0 looks like it's 1. Let's look about these, or let's look at what happens when 3 is our base. So 3 to the 5th is 243, and you can use your calculator for this. 3 to the 4th is 81. 3 times 3 times 3, 3 times 3 is 9, times 3 again is 27, right? 3 squared is 9. What is the pattern? When I go from here to here, from here to here, from here to here, every time I'm dividing by 3. And that makes sense because that's our base, right? So 9 divided by 3 is 3. 3 to the 1st is 3. We know that. Well, what is 3 divided by 3? It's 1. Okay, so pause for a second, pause the video if you want to, and think about what happens if 10 is the base. What happens when 10 is the base? So hopefully you'll notice that at every step going down, I'm dividing by 100, right? So 100, I'm sorry, not 100, divided by 10, because that's the base, that's my base. I'm dividing by 10. So every time I'm dividing by 10, 100 divided by 10 is 10. And that makes sense because I know that 10 to the 1st is 10. Well, if I take 10 and divide by 10, what do I get? 1, right? Well, let's look. Do I see a pattern happening here? 3 to the 0 is 1. 2 to the 0 is 1. 10 to the 0 is 1. Anything to the 0 power is always going to be 1. So let's look at some examples. And this is our rule right here. Let me circle this for you. Any number or variable raised to the 0 power is always 1. So this is our rule. Any number or variable raised to the 0 power is 1. And you can pause the video and copy this rule down. And then I have some examples for you as well. And I want to talk to you about them. So example number 1, x to the 0 power. Just like 2 to the 0 was 1, 3 to the 0 was 1, 10 to the 0 was 1. Remember, x is just a variable. X just represents any number. So any number to the 0 power is also 1. Okay, example 2. Notice I have this set of parentheses here, all raised to the 0 power. Because this whole thing is being raised to the 0 power, remember we said like the power to power rule tells us we should like raise the 4 to the 0, and then we multiply the exponents. This is really y to the first. What's 1 times 0? 1 times 0 is 0, right? So 4 to the 0, anything to the 0 is 1. So this is like 1. Y to the 0 is 1. 1 times 1 is 1. So a rule of thumb for you, if I have parentheses and I have like 857 x to the 10th, y to the 3rd, z to the negative 257, if that's all raised to the 0 power, if the whole thing is in a big parentheses and it's all raised to the 0 power, that whole thing is going to turn into a 1. Now, that's different than example number 3, because I don't have parentheses, right? Not everything is raised to the 0 power. Let's think about what this is saying. This is saying negative 7 times z to the 0. Well, I know that anything raised to the 0 is 1, but is the negative 7 being raised to the 0? It's not. That 0 exponent is only with the z. Just like if I had like 5x squared. This means 5 times x squared. 5 times x squared. Only the x is being raised to the 2nd power, not the 5, right? So let's think on this some more. Negative 7 times z to the 0. So the negative 7 times, that doesn't change. But the z to the 0 is going to turn into a 1, right? Because anything to the 0 power is 1. And so now I have negative 7 times 1, and when I simplify it, I get negative 7. Now, I just want to reiterate one more time. If there had been parentheses, if this had been negative 7z in parentheses to the 0 power, then that's kind of like example 2. The whole thing's in parentheses, and my answer would be 1. But that's different. This is different than this, right? Okay. So here's some practice problems that I'd like you to try. If you could please just pause the video for a minute and then try these practice problems on your own. When you unpause, we'll go over them. Okay. Here are answers to those practice problems that you just worked on. Now, it might have been tempting, because I see a lot of 0 exponents. It might have been tempting to just say 1, 1, 1, 1, 1. All the answers are 1. But not all of them are 1. And I want to point a few things out. Look at number 2. Number 2, I have the parentheses, and the negative is in the parentheses, right? So that whole thing is 1. As opposed to number 6, do I have a parentheses? No. So number 6 is saying like the opposite of 3 to the 0. Well, 3 to the 0 is 1. What's the opposite of that? That's how we get that negative 1, right? And then even things like number 7. Number 7, this is the opposite of negative 2 to the 0, right? Negative 2 to 0 turns into 1. We want the opposite of it, so that's how we get negative 1. Number 8, I don't have parentheses. The only thing being raised to the 0 power is the z. This means like x times y times z to the 0. So the only thing that turns into the 1 is that z. Same thing with number 9. This is negative 9 times x to the 0. Same thing with number 10. Negative 9 times 7 to the 0. The 7 is being raised to the 0, but not the negative 9. Number 11 is definitely a little tricky. So number 11, a plus b to the 0. Remember we said it doesn't matter. If I have a whole bunch of stuff raised to the 0 power, the whole thing turns into 1. But that's different than number 12. I don't have parentheses. Think about like PEMDAS. PEMDAS. So I would simplify in the parentheses first. So for example, if A was 3 and B is 7, it would be like 3 plus 7 to the 0 power. And then it would be simplify in the parentheses first and raise it to the 0, which is 1, right? But over here, if A is 3 and B is 7, PEMDAS, there's no parentheses. I have to do exponents first. 3 to the 0 is 1. 7 to the 0 is 1. Then I would add these together and get 2, right? So A to the 0 is 1, B to the 0 is 1, and I add them together. Okay. All right, so that's all we got for 0 as an exponent. Let's talk about negative exponents. So 0, we're going to kind of continue to use this pattern. So negative exponents, this should look familiar. This is kind of what we just looked at. And remember our patterns. At every step, we're dividing by 2, dividing by 2, dividing by 2. And if I go upwards, I should be multiplying by 2, multiplying by 2. And you can see that always is going to work. So the pattern's going to continue even with negative exponents. So, all right, 2 to the negative 1, well, I need to take this 1 and divide by 2. What's 1 divided by 2? 1 divided by 2 is 0.5, or in other words, 1/2. All right, 2 to the negative 2, well, I need to take 1/2 and divide by 2. I'll do my work over here to make it so that you can kind of see, so I can have some room. 1/2 divided by 2. When I divide with fractions, I have to multiply by the reciprocal. So I can keep the 1/2. I can change the division into a multiplication, but now I need to take the reciprocal of 2. So 2 is 2 over 1. The reciprocal is 1/2, right? And when I multiply fractions, I multiply the numerators. 1 times 1, 2 times 2. So this is 1/4, right? And then 2 to the negative 3rd, I would take 1/4, so it would be 1/4, and I would divide by 2 again, right? Well, just like we did, 1/4 divided by 2 is really 1/4, keeps the same. I change the division to a multiplication, and I change the 2 to a 1/2. Keep, change, flip, right? I have to multiply by the reciprocal. So this is 1 times 1, which is 1. 4 times 2 is 8. Or 8, sorry, so 1/8. All right, okay, let's look at 3's. What happens when I have my 3 as my base? So the pattern, I'm dividing by 3, right? Divide by 3, divide by 3. 3 divided by 3 is 1. What's 1 divided by 3? 1/3, right? What's 1/3 divided by 3? Keep, change, flip. 1 times 1 is 1. 3 times 3 is 9, right? 1/9. What's 1/9 divided by 3? Again, keep, change, flip, right? I'm going to change the division into a multiplication. 1 times 1 is 1. What's 9 times 3? 27. Now, hopefully you're going to start to see this pattern happen. So if I go back and look at my answers for my negative exponents when you have base 2 or base 3, I want you to notice 2 to the 1st, let me try and erase some of this actually here. Here we go. And you can see this a little bit better. Okay, so if 2 to the 1st is 2, 2 to the negative 1st is 1/2, right? 2 to the 2nd is 4. 2 to the negative 2nd is 1/4. 2 to the 3rd is 8. 2 to the negative 3rd, 1/8. So question for you. I could quickly figure out what 2 to the 4th is because it would be 8 times 2, right? So if 2 to the 4th is 16, what do you think 2 to the negative 4th is? It's going to be 1 over 16. Let's see if that pattern is true over here for the 3's. Let me get rid of this again. 3 to the 1 is 3. 3 to the negative 1 is 1/3. 3 squared is 9. 3 to the negative 2, 1 over 9. 3 to the third, 27. 3 to the negative 1/3, 1 over 27. All right, let's see if we can now continue this pattern with the 10s. So what if 10 is my base? Again, I'm dividing by 10, or I can think, oh, I know 10 to the first is 10, 10 to the negative first, 1 over 10. So this should be 1 over 100. 10 to the third is 1,000, so this should be 1 over 1,000, right? So this rule is definitely, I think, the most difficult. But basically, it's kind of like we take the positive exponent and we just make it into a fraction. So here's going to be my rule. So this is going to be your rule that you can copy down in your notes. So this is a big one. You are never allowed to have negative exponents in your final answer. They always have to be simplified. So you're never allowed to have negative exponents. When you have a negative exponent, you're going to flip the base and the negative exponent to the other side of the fraction. And then the exponent actually becomes positive. When you flip, the exponent becomes positive. And then here's an important note as well. You can have negative bases, and I'll show you what I mean by that in just a second, okay? But pause the video if you need to copy down this rule for a second. And then let's try some example problems. So x to the negative second. I can't have that negative exponent in my final answer. So when I have the negative exponent, I'm going to flip the base to the other side of the fraction. So this isn't a fraction, right? But I can make it a fraction by putting it over 1. So the negative exponent is going to flip this base to the bottom of the fraction. So the x comes down onto the bottom, and when it does, it makes the exponent positive. Now, I have this fraction with the x squared on the bottom, but there's nothing left on the top. So if there's nothing left on the top of a fraction, I need to put a 1. Final answer is 1 over x squared. Okay, example 2, 7y in parentheses to the negative second power. So this is actually kind of like a power to power with a negative exponent. So I could think of this as a power to power and say, okay, now I need to do like 7 to the negative second and y to the negative second, because this is like a 1. So 1 times negative 2, right? And now I'm not allowed to have those negative exponents. So I need to flip to the other side of the fraction. Well, wait a minute. There's no fraction. I make it into a fraction by putting it over 1. Now this negative 2 makes the 7 flip to the bottom. So this is going to become 7 to the positive second. And this negative 2 is going to make the y flip to the bottom as well. So y to the positive second. Just like in example 1, I don't have anything left on the top of the fraction, so I can put a 1 there. And I also need to simplify this. What's 7 squared? I'll call it here. So it's like 1 over 49 y squared, because 7 times 7 is 49. Okay, example number 3. Notice I don't have parentheses here. So the only thing being raised to the negative second power is the z. Kind of like what we talked about before, there's 0 as an exponent. This means 10 times z to the negative second. So I got to get rid of that negative exponent by flipping it to the other side of the fraction. But what is that negative 2 flipping? It's only going to flip the thing that it's connected to. So the -2 is only the exponent for the z, not the 10. So this z is going to flip down to the bottom of the fraction, and it's going to become a +2. The 10 doesn't move, though. The 10 stays at the top, and nothing can be simplified. So that's my final answer, 10 over z squared. All right. Here's some practice problems. We're going to start simple and then get a little bit more complicated. Pause the video, try these, and then when you unpause, we'll go over them. Okay, so let's go over these. Here's your answers. And you're going to notice, like in this first example, right? Remember we said the negative exponent tells you to flip the base that it's connected to the other side of the fraction. So it should become like a to the first on the bottom. Nothing's left on the top, so I can put a 1. But what's a to the first? A to the first is just a, right? Look at number 2. 2 to the -2, the exponent, the -2, makes the base of 2 flip to the bottom, and it becomes 1 over 2 to the +2, right? That's here in this step. But then I can't leave 2 to the second. I have to make sure my exponents are simplified if I have them. So I know 2 squared is 4, so my final answer is 1 over 4. All right, so take a minute, check your answers, pause the video if you need to. Okay, let's look. What happens if the negative exponent is in the denominator? I know you're thinking that, right? So what if I have 1 over 3 to the -2? The rule is still the same. The negative exponent tells me to flip to the other side of the fraction. Well, in this case, if I start on the bottom, the other side of the fraction is the top, right? So this becomes like 3 to the +2. Now nothing's left on the bottom. If nothing's left on the bottom, I could put a 1, right? But I got to simplify this. 3 squared is just 9. Do I need the over 1 part? If the 1 is on the bottom, left on the bottom, you don't need it. If the 1's on the top of a fraction, you do need it. Okay. So try this example down here. 1 over 4 to the -1. The -1 tells me to flip that 4 to the other side of the fraction. So it becomes 4 to the +1. Nothing's left on the bottom, so I can put a 1 there. Well, 4 to the first is just 4, and then I don't need the 1 on the bottom of the fraction. All right, this example on the top right, a to the -6. The -6 tells me to flip to the other side of the fraction. It was on the bottom, so I'm going to flip to the top, so a to the +6. Nothing's left on the bottom, so I'm going to put a 1. I don't need that 1, though. So fully simplified is just a to the 6. And very similarly, negative exponent starts on the bottom. I need to flip it to the other side, which is the top. So t to the 5th. Nothing's left, so I have a 1. And then just simplified, that's t to the 5th. Okay, pause the video here. There's some practice problems for you to try. Pause the video, try these, and then when you come back, we'll go over them. All right, hopefully you're able to try some of these. Here are your answers. Remember that if you have a numerical base, like in number 2, like 2 to the 2nd power, I need to make sure I simplify that. Look at 9 and 10. 9 and 10 are pretty tricky. So I think of 9 and 10 as like a power to power. So like the negative exponent is to, to everything in the parentheses. So I got to raise everything to the negative first. So my first step was 2 to the negative first over 3 to the negative first. But then I'm like, oh, I can't have these negative exponents. So that negative 1 makes the 2 flip to the bottom, right? That's how I got this down here. This negative 1 makes the 3 flip to the top. That's how I got the 3 on the top. So then I have 3 to the first over 2 to the first, which is just 3 over 2. And then very similar with number 10. This is just a power to power. So it's like a to the negative 1 over b to the negative 1. The negative exponents tell me to flip the a to the bottom, flip the b to the top, right? And then simplify from there. Okay, that is all I have for you with 0 and negative exponents. I know that was a lot. Thank you so much for watching. Have a great day.